have gone through the power rule, the sum and difference rule. We learned that the derivative of constant is 0. And so we have gotten through what is generally the easy derivative rules. And now we go on to some little bit more complicated derivative rules. And the first one that's a little bit more complicated is the product rule. What happens when you have two things multiplied together? So we can, at this moment, we can multiply it all out. And if we multiplied it all out, I hope you see that you would get an x to the 5, and then you would get a 5x to the 4, and you would get a minus or a plus 3x cubed and a minus 15x squared. It would not be hard to multiply that out, and then you could use your product rule and sum and difference rule and figure out the derivative right away. However, sometimes it might be annoying to multiply things out, so it would be sure nice to figure out a way that we could do the derivative of this if we didn't multiply it out. And based on what we learned with the sum and difference rule, wouldn't it be nice if we could just take the derivative of the first one and multiply it by the derivative of the second one? That would be nice. And it does not work. Okay? And actually Leibniz said the same thing. He's like, I want that to be my first guess. I just want to do the derivative of one times the derivative of the other. And he found out very quickly that it doesn't work. So for example, we have x times x to the 4th. If you multiplied it out, you would get x to the 5, which is really easy to find the derivative. Because you bring the 5 in front, subtract 1 from the exponent, you get 5x to the 4th. Notice that if you did the derivative of them separately, the derivative of x would be 1, the derivative of x to the 4 would be 4x cubed, and if I multiply them, it doesn't equal that. So I can take a simple example, try what I think, and find out that it doesn't work. So a little bit less logical, you decide on the following rule, that if I have two things multiplied, and I'm going to color code things here so that you can really see what's happening. I'm going to color code one function in yellow and the other function in green. So we have the yellow multiplied by the green. The derivative rule says this, and you will hear me say this so many times that it's my hope that you start hearing this either in your own voice or maybe later on you're in calculus class and you hear my voice again. That's perfectly fine. But the product rule works like this. When you have two functions multiplied together, then the derivative is you keep the first function the same and multiply by the derivative of the second function. Then you keep the second function the same and multiply by the derivative of the first function, which can be simplified to just keep one the same. It really doesn't matter which one you keep the same first, because I'm adding here, right? You see you have two terms that are added. You always have one the same times by the derivative of the other. And it doesn't matter which one you have first. So it's like, you don't even have to keep the first one the same. Keep one the same, multiply by the derivative of the other one, then keep the other one the same, and multiply by the derivative of the other one. I like to say keep the first one the same, multiply by the derivative of the second one, keep the second one the same, the derivative of the first one, because it lets me use words that at least, when I say the other one, the other one, the other one 5 times, you're like, which one was the other one again? So we always keep one the same, multiply by the derivative of the second one, then keep the second one the same, multiplied by the derivative of the first one. Two different notations. So this is using function notation. Okay? If I do the same color coding and I didn't write things as a function, so I have u times v, I keep the first one the same, and then dv dx would be the derivative of the second one, and then I keep the second one the same, and multiply by the derivative of the first one. So what we have to be able to do is recognize when there's a product. So, here's one that we could do with the product rule, but we can also, off to the side, say this would have been one we could have done before, because this is really easy to distribute. X squared times 2x would be 2x cubed, and x squared minus 1 would be minus x squared. So I know from yesterday's lesson that I can bring the 3 out in front, subtract 1 from the exponent, bring the 2 out in front, subtract 1 from the exponent. I know the derivative using my derivative rules from yesterday. There's nobody that's like, oh, I wish we could use the definition of the derivative for this one instead. Is everybody okay with the shortcuts? Because if you want, we can just go back and do everything the long way. No? Alice is okay? First unit, was it painful? Doing it again? Now, what you have to do if you're going to use the product rule is to see where the multiplication is. Sounds pretty simplistic, and it can be, but sometimes it's tricky. Can you see that this is x squared times the 2x minus 1? And if I color-coded this the same, I'm imagining this one is multiplied by that. The computer program has a built-in thing that tries to assume you wanted to draw a straight line. So when you draw a line that is a little bit not straight, it like helps you out and straightens, which is really annoying when you're trying to highlight a parabola, which I guess this one would have worked. But sometimes it makes straight lines when you don't want to. Anyways, so now we have, and your product rule says keep the first one the same. So I just write x squared and then multiply by the derivative of the second one. So what's the derivative of 2x minus 1? Well, the derivative of 2x would be 2. The derivative of a constant would be 0. So this whole thing is just going to be a derivative of 2. 2 minus 0. Plus, now we keep the second one the same, 2x minus 1, and multiply by the derivative of the first one. And the yellow one's derivative, bring the 2 out in front, subtract 1 from the exponent, and we get 2x. If we multiply this all out, can you see that you would have 2x squared plus 4x squared minus 2x, combine those like terms, and you get 6x squared minus 2x. So if the question actually said, we would like your answer in simplest form, I think the original method that we did here in the blue box is simpler. It got us the simplified answer faster. Sometimes you're not required to get a simplified form. You would be okay to leave it like this. Then it would be a toss-up. I might like the product rule better because I can just write it all in one step instead of simplifying first and then find my derivative. So we have some options. trust me, we will get some that there is no way that you would want to simplify them out in any manner. But right now, we're just learning different techniques that we can use. Again, not too bad for multiplying out. But if we wanted to do it directly, we could just go, okay, first of all, do I recognize two things multiplied by each other? The brackets are really nice. I'm going to add the green dot there. If you're liking the color coding, to really see that this one is first, and this one is second, perfect. I have the yellow one multiplied by the green. So for my product rule, I keep the first one the same. Wow. Multiply by the derivative of the second one. Well, the derivative of 2x is 2. The derivative of minus 1 would be 0. So that derivative would just be 2. Plus, keep the second one the same. Multiply by the derivative of the first one. So I bring the 4 on in front, subtract 1 from the exponent. The derivative of 7x would just be 7. And we have our answer in one step. If you had to simplify this and multiply it all out, that would still take some time. But most of the time, you'd be allowed to leave your answer unsimplified like this. And once again, you get your answer in one step. Back to grade 9. Except when you write your answer, if someone is looking at what you did, it looks a little bit like magic. Like, you did, what did you do? Right? And if you, then you just respond to the person that doesn't know, just use the product rule. Okay. And then they will not ask any more questions. They weren't really wondering what you did, but okay. So we want to find the derivative. This notation, this ddx says find the derivative of all of this. I do a little preliminary stuff and I see the square root, so I'm going to have to do some changes, because right now I've got a rule for multiplying, but within that, so far the only thing or the only type of function that we know how to do the derivative of with a shortcut is x's with powers. We know the power rule. If we had anything else built into this, we might be in trouble. So that square root, I'm going to take the time first to change this to an x to the 3 halves plus x. Sorry. I was going to talk about how I was strategic with brackets, and then I got unstrategic with my brackets. Okay? So when you have a question with multiple brackets, it's very easy to get confused with the brackets, especially if all of your brackets look the same. So you will see some teachers change their brackets and have, like, I'll use a square bracket, then a round bracket, then a squiggle bracket, then start making up different brackets as they go along. One of the things that I like to do is I like to use the same kind of bracket but make them different sizes. So I had a big bracket to start and then a littler bracket, and when I closed the littler bracket, I made it the same size. And then I had, okay, another bracket of this size so I can close it, and then a big bracket at the end to say the whole thing. Again, if you like to color code this, we've got our multiplication happening. There's our two functions. One multiplied by the other. So if I'm taking the derivative, I would my derivative will equal, keep the first one the same, multiplied by the derivative of the second one. Well, in the green, the derivative of 1 would be 0. So 5x squared, we can bring the 2 out in front, subtract 1 from the exponent, we would get 10. Then add. Now keep the second one the same. Multiplied by the derivative of the first one. So x to the 3 halves, I would bring my 3 halves out in front. Again, you're getting pretty good at subtracting by 1. Plus the derivative of 1x will just be 1. And as we go through our derivative rules, one of the unfortunate consequences that happen is sometimes you forget what you're doing. Right? Like what is happening here? Okay, so a reminder, what does a derivative do? This is now the formula for the slope of any tangent that you could draw on this original function. This is a crazy original function. You have no idea, well, I hope not, because then I'd be a little scared. I have no idea what this graph looks like. I look at this and I have no idea what that graph looks like at this moment. And I have no idea what the tangents look like anymore. But this apparently is the formula for all of those tangents. Now, breaking it down to something simple, and the reason I thought about this, is when I did the derivative of just x, and I got 1, that's something that when you do the derivative of something that's just an x is a straight line. Does it make sense that any tangent that touches the straight line is exactly the same as that straight line? What is the slope of y equals x? Well, y equals mx plus b, the slope is just 1. So at least this part here, I was like, that made sense to me. That this slope of, when I found the derivative of just the x and I got 1, I thought about, what does it mean? This is a tangent to that function. Any tangent on a straight line should be identical to that slope of that line. So at least that part had some meaning. Okay. I'm going to add a question to have a little bit of fun. One that it reminds me of the first time that I got to teach calculus. Very exciting. It was my second year of university, and I applied and was hired to teach the lab component of the first year university calculus class. So what happens in universities is sometimes some courses have lab components connected to them. So a normal university class, which is a 3-credit hour class, usually a 3-credit hour class amounts to 3 hours of lessons per week. And they decide how they're going to give you that 3 hours of lessons. At University of Manitoba, you could have some classes that run Monday, Wednesday, and Friday, each one being 50 minutes long, which is close to an hour. The university professors worked it out, so like, yeah, we'll give you 3 hours of lesson, but we'll take a little bit of time. And the students don't mind. It's really, you get, so you have 3 50-minute classes, or if you had classes on Tuesday and Thursday, those are longer. They're like an hour and 15, hour and 20 minutes each, and then you only have 2 of them. And then evening classes are 3-hour sections all in a row. And you have to sit through a whole, you get everything you learn in the week in one sitting. And those are painful, right? Right, you think calculus in the morning is sometimes painful and you only have an hour of it. And 3 hours in a row of the same subject can be very tough. Okay. So, I was teaching the lab component because some classes say that it's not enough for your 3 hours, you have to go to an additional session where they review the stuff you learned during the week, And that's what I was in charge of. And at that class, I was doing a product rule, similar to this one. So we'll do the product rule first, we'll see the answer, and then I'll tell you the story of what happened in my calculus lab that I taught for the very first time. I'm going to have a little bit of fun because my original function, we're going to have 3x to the 4 plus 2x multiplied by 7x cubed minus 5x, and then multiplied again by 3x to the 5 plus x to the half. We have a little bit of a problem because as far as product rule goes, can you see you have a multiplication there, and you have a multiplication there. But our product rule only works for 2 multiplications, not 3 multiplications. So what we're going to do is we're going to break this up into 2 multiplications. Within one of them has its own 2 multiplications. So I'm going to just add a big set of green brackets there. And I'm going to take out my colors and just underline here that I have this one multiplied by this one. Okay? And then I want you to notice that in the green one, you have multiplication. In the green one, I have this one multiplied by this one. And this is the powerful thing about calculus, is if you can keep the rule in your head working through, then we can do complicated questions. So the product rule says keep one the same, derivative of the second one, keep the second one the same, derivative of the first one. So let's apply just those words to this question. I keep the first one the same, which is my yellow one. 3x to the 4 plus 2x multiplied by the derivative of the second one. Sorry, I'm already preparing you for this. Okay? I did not have that luxury of a smartboard in my first university lab, but I did have a very long chalkboard. Okay. So I kept the first one the same. Students are usually pretty good at that part. Now I do the derivative of the second one, which is the one I underlined in green. But when I look at the derivative of the second one, I have a product rule. So I'm going to put this green bracket here. The derivative of the second one would be a product rule which says keep the first one the same, 7x cubed minus 5x, multiplied by the derivative of the second one, which will give me 15x to the 4 plus 1/2 x to the negative 1/2, plus keep the second one the same, 3x to the 5 plus x to the 1/2, multiplied by the derivative of the first one, 21x squared minus 5. Close the green bracket. Where was I? And this is the hard part about calculus. You're going to have these rules, and you have to keep track of where you were going. I kept the first one the same, derivative of the second one, which was its own product rule. And then I have to go plus, now I keep the second one the same. I put that green square bracket there, because now I'm keeping the second one the same. Which is all of that, multiplied by the derivative of my first one, which is the yellow, Bring the 4 out in front, 12x cubed plus 2. And we had a product rule inside of a product rule. Again, the rule didn't change. But when we look at the answer, now all of you drop the course tomorrow because this was scary looking, and I'll feel very guilty. Okay? It looks crazy, the answer. And yet it's still like a grade 9 question. We just did it in one line. Just looked at the original question, wrote it out. We had to keep the words and the thoughts in our mind. So what did I do? I kept the first one the same. The derivative of the second one was huge. Plus, kept the second one the same, even though it was huge. Derivative of the first one. And when I did the derivative of the second one in the green brackets there, I had a product rule inside of it. So it became very, very long. We could do one where we multiply 4. No, it would be even longer. So what had happened is sometimes with the product rule, the derivatives become very long. Like I couldn't even fit this in one straight line. But in the class that I was teaching, my first time teaching calculus, I had a long board so I could keep writing over 2 chalkboards with it. And I don't know why they had this in this classroom, maybe to make the teacher feel more important, I'm not sure. But there were wooden platforms at the top so that I could imagine being even bigger than you guys, like really tower over, make sure that you're learning, I'm not sure. So they had 3 wooden platforms across the top. And I'm writing out this derivative. I have my very nice calculus textbook in my hand. And there were chairs just like here at the front. And the derivative got so long that I had to put my knee on the chair and lean over. And I didn't know that one of the legs of the chair was in the crack between 2 of the platforms. And as I leaned on the chair, the force pushed platform a little bit, which caused the leg of the chair to go down into the crack, which caused me to all of a sudden fly off. And it was on the last platform, so not only was I falling, but I fell off onto the floor. And basically, it was a good thing I was a volleyball player, because I did a very nice volleyball dive in the middle of the calculus lesson. And every student said that was their favorite class of the year. So, I don't know, is there something about enjoying watching your teacher possibly getting injured? Like, oh, you should really try to teach by standing on a desk, Mr. J. Hopefully you'll fall. I'm not sure. But anyways, that is what, when I do the product rule, I'm always reminded of that time where I had to do a volleyball dive in the middle of a calculus lesson. And I managed to keep the textbook up. Okay. They're getting more complicated. You need to be able to do this well. So, I'm going to give you time to work on this. When you get your answer, it's fine if you don't simplify it, but after you've done a bunch, then start to check the answers in the back and see what does the simplified form look like and try to determine how you would go about simplifying it if you could, because that's a really good exercise in practicing your algebra skills.